Hi, this is the first in my series of composite area problems for 7th and 8th graders. This example requires us to find the area of this strange figure. We don't have a formula that will help us to find that area, so we're going to have to figure out how to solve this problem of finding the area. Now remember that the area means the space that the figure takes up. It is not the perimeter, which is the distance around the figure, that we're looking for. If it were, we would just add up all these numbers and we'd be done. But we need to find the space inside that the figure takes up. So we have some formulas to help us with that. But first, we need to divide this figure into shapes that we recognize that we can find the areas of. That means squares, triangles, parallelograms, trapezoids, any of those figures that we already have formulas to help us with. Then we have to find the areas of each of these shapes. And then we simply add the areas together and we'll have the area of the whole figure. So what figures can we divide this shape into? The first thing I notice is I could draw a line right here and divide this into a small rectangle and a large rectangle, which is exactly what I'll do. I could also have drawn a line this way and made a medium-sized rectangle and a little bit larger rectangle. Either way would have worked. We'll stick with this way since I already drew my line. Let's find the area of the smaller rectangle. We know that the area of a rectangle is equal to base times height. So what are the base and the height of this rectangle? I see that the base of this rectangle is 8 feet and the height is 5 feet. So the base is 8 and the height is 5, and 8 times 5 is 40. And the units that we give area are square units, so it's 40 square feet. Now I need to find the area of the larger rectangle. I can see the base for my larger rectangle is here, 28 feet. And the height for my larger rectangle is here, 13 feet. It's not 18 feet because this 18 was meant to describe the distance from the top of the figure all the way to the bottom, and it includes this 5-foot side of a smaller rectangle. So we won't use the 18-foot number, we'll use the 13-foot number, which describes the height of the rectangle we're looking at. So the base of our larger rectangle is 28, and the height of our larger triangle is 13. So 28 times 13, last time I checked, was 364 feet squared. Now all we have to do is add these two numbers together to get the area of our composite figure. So 364 plus 40. 4 is 404 square feet. And that is the area of our combined figure, the composite area of this strange little figure. Next, we'll do a little bit more complicated problem in our composite area example number 2.